just like this man, alhamdulillah, who's worked for ComEd for several years. You know, he's an old timer. He's a nuclear scientist. He's a strategist at ComEd. He's a strategist at, and they're struggling right now of how to deploy millions, and they're talking about billions of devices in the future. So it really would be very good for all of us to sit down and see their vision and their 101 RF class and how they're approaching deploying these devices. Because for us, I mean, alhamdulillah, the more we learn and the more we tailor-made our solution, you know, there's an opportunity for us to work with them, to be able to help them, you know, just from our experience, alhamdulillah. The other thing is, if you look at them, they tend to be the people that tend to be in the office. They're not going to be the people who are going to be working out these issues and these engineering and that. And so we could be a great complement to them. And so, inshallah, when we put this on, and I'd like to see all of you, inshallah, if you can all make it. It's a great opportunity. I mean, the guy's a visionary also, alhamdulillah. And he can give you an idea of where they're going and where they want to be. And this is a phenomenal opportunity for them to get into a very huge.
So to that point, like Hussein was saying, is like people are, as you said, people are the degrees of freedom that we have when we're designing and deploying a network. You always say, I wish I had, I wish I had, I wish I had. So the things that we have to do selecting of frequencies, selecting of power, selecting of all these things, those are the fundamentals that you have when you deploy a network and design those parts. Those are the only things that you have to play with. You can change your frequencies, make them narrower, change your power, put them in different order. So talking about, you know, like we said, listen before talk, that was the Wi-Fi, the old Wi-Fi protocol. That is, mesh decides, like Hassan was saying, they fixed a different problem. When you have just a little bit of data to send, there's no one sending, let's say that we were a mesh network, and the way we talk, no one talks directly to me except the guys next to me. No one talks to me except for the guys who are next to me, and so that means that you guys can talk to each other, and you guys can talk to each other, but nobody used very high power. This is a very simple mesh, just to try to stay together. It's a very simple mesh network, maybe the very first mesh network. It took advantage of, you know, let's all speak lowly. Not everybody lower your voices. Talk to him, and let him talk to the guy next to him, and if he has something to say this is from Isa, and this is from so-and-so, and this is from so-and-so, and you're passing the information along, and it's got to come to me. And I will understand everybody saying this is so-and-so's message, so-and-so, okay, send it out, okay, bring it back in, and round it back, and go back in and out. And at the simplest form, this was mesh. And what this was really good for is like, okay, because you don't need much to just send a little bit of data, the bandwidths shrink. It's the same exact, those tools that we just talked about, bandwidth, power, frequency, are the tools that you have in the physical interface world to do things. And so what they did in mesh is like, okay, bring these frequencies, the bandwidths way down, your sensitivity to noise goes down, and so now you can hear really, really weak signals, but you know what? Since you're only talking to him, and maybe the advanced systems later, 10 years ago, they decided, you know, if that guy's not available, I've got enough sensitivity. I can talk to Sam. I can skip him in case that guy breaks down. I'm not going to break down everybody, or in case that path breaks down, I can go this way. So there isn't, no one gets stuck in this loop, and that software comes and fixes it. So in the hardware, you make the system flexible to change bandwidths and make them narrow, and change the amount of data that you put in. And then once it's put together, or before you put it together, you decide, if I have 100 users on here, and if everybody only sends voice, then every transmission might only need about, let's say, 20 kilobits per second. And we have to talk about this probably another time too, is talk about where do these data rates come from. When someone says, I get 10 megabits per second at home, I just paid Comcast so much per month. It's been 5, I'll only 10 megabits per second. But what's the difference? Can I see 10 megabit difference? What kind of applications need 10? What kind of applications need 1? How do you tell the difference between what it is that you need? And so in these low bandwidth systems, if everybody is only using 20 kilobits per second, and he takes his information and sends it to the guy next to him, but he also has 20 kilobits. So he has your 20 and his 20. And that guy has his 20, your 20, and that 20, and he's carrying it. And he has everybody else's 20. When you look all around the room and everybody hands over a 20, And if I have 50 users, and everybody's carrying the bandwidth for everyone else, the guys at the end have to be capable of carrying 50 times that 20 kilobits per second, because they're the final guys who will most likely, the guys closest to me, will be the ones carries the heaviest load. And so when you deploy your network, you look at how many nodes. Like if you have 10,000 nodes, and if everybody's only sending 20 kilobits per second, one important thing is, can I get the bandwidth that I want? Eventually, everyone, this is a key word, eventually, everyone will be heard. But the question is, besides the amount of throughput that I want, so imagine yourself, you are on the internet at home, again, and you decided to do a Skype call with somebody, right? Or you're doing Vonage, and you're on your home network. And you have things that you're important. What's important to you as a Vonage user, as a guy who's making phone calls? What's important to you when you're talking to somebody? Surah. So, well, I mean, what do you mean a surah? What is it? The voice quality. Does it sound like the guy is in a tin can? صوته مخروش ولا صوته واضح كأنه أمامي? Right. That's called voice quality. And people have so that there's these metrics, these ways to measure voice quality, so that we don't disagree on it. There's a way to measure it and to quantify it, and it's called like MOS scores and other types of scores that people measure to say that the voice quality is good, it's equally good to the other one. And the other thing is, like you said, time. So how good does it sound? And then, am I getting everything that's being sent? So with voice is a very interesting thing because it has a tolerance because of our ears. You know, if suddenly when the network is not busy, everything that ISAR says, because it takes, let's say it takes 1 microsecond for every hop. It doesn't take 1 microsecond, just making an example. If it takes 1 microsecond every hop before it gets from you all the way back to me, that's what we call latency. And for any time you want to say something, it can take that many hops. Let's say it takes 10 hops. It takes 10 microseconds for the data that تبعت لي حتى يوصل. But 20 microseconds مش مشكلة. 10 microseconds مش مشكلة. A voice, when you want to deploy a voice network, things you have to worry about, how does the latency change, which is called jitter. How does it change? It jitter, right? Between, so when you have one piece of data, and then the next piece of data is coming in from your voice, and then voice is the same thing. بتقطع الدata that you're saying, you create a digital signal from it, and then you put it on the RF and you send it out. And when it goes out on the RF, it has that same character in it, but it's built into the RF and you can't see it because it's embedded. It's shifted up in frequency. So when it comes to me, I'm hearing, okay, I have what's called the opposite of the codec. I have something on the other side that's detecting the voice and it's converting it, and I can convert it back to a phone call for somebody behind me who wants to hear it on the other side. So that starts coming in. And if, while there's nobody on the network, I'm getting the signals every time you send it. It's coming to me every 100 microseconds because there's 10 people that are transferring your signal to me. So every time you send something, it might be delayed 100 microseconds. Suddenly, everybody gets busy here, and we added 1,000 more users in the past, in the path. And you can't jump from person to person. Suddenly now the latency increased by a factor of 100 times more. Now, as you add and add and add users, if the latency gets beyond 100 milliseconds, for example, our ear can hear 100 milliseconds. If for some reason the data is delayed more than 100 milliseconds, I can hear a pop. I can hear it sounding that it's not a good quality signal, and you will be, as a user, unhappy if the latency starts to get above 100 milliseconds. And then there's something that varies in these networks, which is depending on how busy everyone else is. If that guy suddenly gets busy, and instead of taking your signal and shifting it right away, he was busy doing something else, and he's delayed a little bit. But it's not the same every time you go through this loop because he wasn't busy this time, someone else was. 10 people were busy and 6 weren't. And so the type of deployment that we're talking about is making a network really large, is being certain that for the application that you want to use it, it's going to work and keep our customers happy. If we're talking video, video is not 20 kilobits per second. We're talking about 2 megabits per second for a decent video. If you want to do HD, high definition video, maybe you'll need 8 megabits per second, maybe 10 megabits per second, or 12 megabits per second. So if everybody had a 12 megabit per second signal that they wanted to send, add 12 and 12 and 12 times 10, that's 120 megabits from this side, 120 megabits from that side. هذا ال AP راح يكون حاله to handle 240 megabits per second of throughput to be able to send that back. It's going to be pretty heavy. So you can start seeing where the limitations of different types of networks come in through mesh. Is if you're handing signal over to every person, then it starts becoming a little bit limited. It's similar to this other model where, let's say, instead of handing it over, everyone can talk to me directly, kind of like the Wi-Fi. بس بالدور باحترام وبالأدب everybody أنا conductor okay لا دورك and as I sense me the smarter I get as the access point because I want to keep everybody happy. I don't want to serve somebody who has nothing to say. I don't want to talk to somebody who has nothing to say because every time I talk to somebody it costs me maybe 5 microseconds or maybe it costs me 5 milliseconds maybe it costs me 10 milliseconds إذا بدي أجي أسألك عندك شيء تحكي ولا لا؟ ليش أسألك وأنا عارف إذا بقدر أعرف هذا الفن في the real skill in these point to multi-point systems. If I don't want everybody to talk through each other and I want to be the master, is how do I know you have something to say? How am I going to know that you have to sense? What's that?
Sense the heat of the electronics.
Yeah, so I mean, but you're 6 miles من عندي. شو بدي أعرف؟ كيف تحسن?
It's in the time. It's in the frames.
So it's like you could create all kinds of ways of how am I. That's the I just gave you the bottleneck of multi-point communications. Is when the guy down there, several miles away, 1 mile away, how do I know he has something to say, unless I'm asking him on a regular basis, or if I give him time and waste time? How do I make my system efficient enough so that I can determine when he has something to say, and how often, depending on the application, how often should I ask him to make sure that I don't have a problem? Like if it's voice, I got to make sure that I have to ask him at least within every 100 milliseconds. If I wait longer than 100 milliseconds before I give him the opportunity to send his data, then we'll see if he mushkila fil voice. The guys who are on their voice calls, they start complaining, and the network becomes really lousy for those users. If it's video, I got to look at I got to look at my users and be practical. Like Sam was saying, when I want to deploy a network, I want to figure out how are people going to use this network. If they're going to be doing video on this network, how often, what's the likelihood, what's the probability that everybody will be doing video at the same time, at the same moment? Right?
For the meter scenario, I guess Sam was talking about, we knew it's going to be once a month on a regular basis. So we know everyone will submit their data at least once a month. And we know the date, we know the time almost.
Yeah. So
How are
for
you gonna solve this?
for something that's scheduled. So let me finish the video analogy first. So with respect to video, let's say that you know that these are common Wi-Fi or common internet users. Instead of having cable at your house, someone gave you a wireless device. And so what you're doing in your device, okay, and I watch videos, I have voice calls, I do these sorts of things. So the access point, because it's a business decision. Sam has to make a business decision. Do I buy a base station that can do a gigabit per second, $100,000 for that? Because I have 100 users on there, and each one wants 10 meg, or each one of these guys wants 100 meg. And so if I want to serve them all the time, guaranteed when they're on the network at the same exact second everybody's doing video, راح يكلف Hussam 20, 50 times more than it should. But Hussam maybe is like, I'm going to do some analysis. How often are these guys asking for video at 10 megabits per second at the same exact time? There's this concept of what's called oversubscription. Right? It's just like for people who are in the airline industry, they always overbook the airlines, right? Their job is to overbook by a certain percentage because over time they've discovered that I can overbook the people who are selling tickets. They can sell 10% over or 20% over the number of seats they have because on average 20% Jewish. And so they're going to be okay. Their job is to get the plane full. Sam's job is to get that access point fully utilized and to keep everybody happy. Once in a while, okay, we'll figure out a way how to get this guy happy once in a while. But if every time the plane goes to boarding, there's 20 people waiting and they can't get a seat, and I have to pay these guys each $200 more every time, he'll be out of business in no time. But your job as network operator is to understand your customers, how they're going to use it, and the probability, and all the probabilities of when people will use things and how, understand your latency, to do a sort of kind of delay between things and what it means for your application, and how much throughput people are going to need and how often they'll use it.
Inshallah, alhamdulillah, if we can put the video on, and if all of you will get a chance to look at it and at your leisure, learn as much as you can about it, because I think our next meeting with Mel will be the strategist for this group. It'd be really good to ask them some very good technical questions, because they're deploying very much like exactly what this man is talking about. They're looking at trying to go from, they went from a few thousand to a few million, now they're looking to do billions. So every one of those steps has inherently a problem and an issues that come up with it, as far as performance, as far as operations and maintenance, and as far as how do you grow the system. You know, one of the things is that this man is absolutely right. Everybody likes to do hardware, which is great, but you can't change hardware like you can't change software. You can't just like add a few pieces of code and just download it and say, okay, now we got a new feature. Oh no. Imagine having to go up thousands and thousands of different towers and pull these wonderful base stations out and changing the hardware internally, and that in some cases that in itself bankrupts companies like now today, because they're not government where they should just have a blank checkbook. So this company has an architecture already, but I think what we would probably want to try to understand is your architecture today that works for millions will also work for billions, and how are you able to introduce enhancements and upgrades in that, things of that nature. And so I think in a live case, it's like you're going from the classroom in many cases to an actual real world application. And I think that's, to us, I mean, we never got an opportunity to do that. We were just thrusted in and basically put in a little lab and that, and we never really got to see the world. I think it's really good for us. I wish we would have had the opportunity to see a real world and then come back and figure out how to design wonderful products for the next 10, 20 years.
We're still young, so.
Alhamdulillah.
Just getting started.
Just getting started.
في حد بدك تاخذه انت شيء ولا you are okay
We
with
can.
the time?
This sound.